Deliberate practice, where learners receive repeated practice on skill components that are at the edge of their competency, helps novices become experts. In traditional cognitive tutors, students get multiple opportunities to practice on one skill, and their problem-solving processes are captured through web-based UIs. Mastery of 3D physical tasks also requires deliberate practice to improve learners' spatial awareness and hand-eye coordination skills on the specific domain knowledge. Beyond text and video tutorials, existing research has explored mixed reality-based guidance and tutoring systems which provide additional visual cues in situ. However, the key elements of deliberate practice are often missing in tutoring systems for 3D physical tasks. First, repeated configuration of a physical object is hard and strenuous. Second, it is challenging to accurately capture learner performance on a 3D physical task to provide adaptive instruction. We propose Rubikon, an intelligent tutoring system for learning to solve the Rubik's Cube. The foundational design of Rubikon is an AR setup, where learners manipulate a physical cube while seeing an AR-rendered cube on the screen. This allows Rubikon to automatically generate configurations of the Rubik's Cube to target learners' weaknesses and help them exercise diverse knowledge components. Following the design principles of cognitive tutors, Rubikon has 4 key components, including task model, task generation, knowledge tracing, and model tracing. The task model specifies the solution paths to solve the Rubik's Cube and determines tutoring behavior. The task generator generates new configurations of the Rubik's Cube to help users deliberately practice. Knowledge tracing computes the user's proficiency on the knowledge components required to solve the Rubik's Cube. And model tracing compares the user's actions against the task model in order to provide real-time feedback on the user's moves. The user interface of Rubikon contains 5 sections: the playground, the goal image, the hint panel, the skillometer, and the controls panel. When a learner uses Rubikon, they first follow a goal to manipulate the cube freely. Rubikon uses extended views to present hidden information and reduce unnecessary cognitive load. When the user gets stuck, Rubikon uses model tracing to provide relevant hints in 3 levels. First, highlighting the target block, then graying out unimportant blocks, and finally explicitly showing step-by-step arrow guidance. As the user completes the goal, Rubikon models user proficiency using knowledge tracing and visualizes their progress of skill mastery on the skillometer panel. For unmastered skills, Rubikon then generates practice that specifically targets those skills. Because of the AR rendering setup, Rubikon is able to dynamically generate new problems for repeated and deliberate practice. Users can complete these practice problems to finish learning the skills. We evaluated Rubikon in a between-subjects experiment with 36 participants, with a business-as-usual baseline condition where users watch video tutorials and use a regular Rubik's Cube. A second baseline where users watch video tutorials and use an AR-rendered cube. And the Rubikon condition where users access the full functionality of the system, including the AR setup and the intelligent tutoring capabilities. We found that learners in all 3 conditions reported a similar level of cognitive load. Moreover, learners who used Rubikon scored 25% higher on the post-test compared to the traditional video tutorial baseline. We further probed into the reasons behind the higher learning gains. Learners in the Rubikon condition had a more comprehensive and balanced coverage of the diverse skill components required to solve a Rubik's Cube during their practice time. However, learners in the baselines had limited exposure, constrained by the physical configurations of the cube. Specifically, many participants in the baselines struggled to match the configuration of the cube in their hands with that in the video tutorial, which increased the preparation cost for the users to engage in meaningful practice. Overall, Rubikon is an example of deeply integrating mixed reality technologies with theory-driven instructional design in order to produce effective tutoring systems for 3D physical task learning.